let's really take a look at some reactions where temperature is going to make a big difference. So the reaction we're going to look at here is the decomposition of sodium bicarbonate, or sodium bicarb here, and it decomposes it into sodium carbonate plus CO2, carbon dioxide, and water. So we can think about calculating that delta G of this reaction. I'll tell you that the change in enthalpy, this is actually an endothermic reaction. It requires heat. It's plus 135.6 kilojoules per mole. So let's go to a clicker question, and I want you to pick out from several choices which of the changes in entropy seem reasonable to you here. So what would you predict the delta S for this reaction to be? All right, let's do 10 more seconds on that. Okay, so we've got the majority, but not everyone. So let's take a look at why this is the correct answer, that it should be plus 0.334. If we're going from 2 moles of solid to 1 mole of solid plus 2 moles of gas, are we increasing or decreasing the disorder? We're increasing the disorder. If we're getting to a more disordered state, then we're going to have a positive change in entropy. We're going to increase the disorder. The only one with a positive delta S is this choice here. So if we switch back to our notes, we can see that, in fact, let's focus on this screen today. Seems to be doing a little better. So what we see is that it's 0.334 kilojoules per K per mole is our delta S. So we can go ahead and calculate our delta G for the reaction. So we're just plugging in our delta H. So our delta H is 135.6. And we're talking about, to start with, let's talk about room temperature. So 298 K times 0.334. So what we end up having for the delta G of our reaction is that it's 36.1 kilojoules per mole. So this is at room temperature. So is our reaction spontaneous or non-spontaneous at room temperature? It's non-spontaneous. All right, but let's take a look at a different temperature. For example, let's look at baking temperature. So if we think about baking cookies, we maybe bake them at 350 degrees Fahrenheit. So that would be 450 Kelvin. Our ovens are usually set to Fahrenheit and not Kelvin. So if we think about this reaction at this temperature, first of all, let me point out why we would be talking about baking cookies for this particular reaction here. Does anyone know what another name for sodium bicarb is? Yeah, it's just baking soda. So this is the reaction that causes your cookies or your cakes to actually rise. So we're producing gas here, and when we're producing that gas, when this sodium bicarb decomposes, we're forming these pockets of gas in our baked goods. So if we bake our cookies at room temperature, obviously they don't bake, and they also don't rise because the sodium bicarb, clearly it was non-spontaneous at room temperature. This reaction just doesn't happen. But if we take a look at baking temperature now, we're going to plug in this new temperature, which is 450 K, and plug this into our delta G reaction. What we find is now our delta G for the reaction is negative 14.7 kilojoules per mole. So in this case, we are dealing with a spontaneous reaction, which is good because this means that when we put our cookies in and we turn it to 350 Fahrenheit or 450 K, the baking soda will decompose and we'll get our cookies to rise a little bit. All right, so one thing that I want